If we placed three brains on a table, one belonging to a billionaire, one to a 25-year-old feeling stuck, and one to a goat, you might expect the billionaire's brain to look entirely different. But beneath the folds of the cortex, their core biological machinery is shockingly similar. A goat needs the ambition to find grass and water, or it dies. That exact same biological drive, the baseline circuitry that pushes an animal to survive, is the same hardware a human uses to pursue a career goal or build a business. The gap between feeling stuck and reaching the peak of human achievement isn't found in the macroscopic weight or shape of the brain. It lives in the microscopic wiring, the physical, structural habits built between individual neurons. This diagram shows the brain's core motivation circuit. Deep inside is a pathway running from the ventral tegmental area, or VTA, to the nucleus accumbens. Evolution built this specific route to release a hit of dopamine whenever you did something necessary to stay alive, like eating or drinking. But watch what happens to this same circuit in the modern world. It gets flooded. Endless scrolling, highly processed sugar, and digital gambling hijack this ancient survival path, feeding it cheap, synthetic hits of dopamine until it physically expands, making you hypersensitive to the next hit. When you find yourself staring at a screen at 2 a.m, unable to put your phone down, you aren't experiencing a moral failing. You are experiencing the physical reality of a hijacked biological circuit demanding its next automated reward. Your daily repetitions act as a construction crew, physically carving permanent structural roads into your brain's hardware. To understand how these roads are built, we have to look at the brain's workshop. You have gray matter, which contains the cells that actually produce electrical signals, and white matter, which acts as the physical cables carrying those signals across the body. When you first learn a new skill, like riding a bike or playing a chord on a guitar, it takes immense conscious effort. But as you repeat the action, the electrical signal fires repeatedly down the same white matter cables, and the connection physically strengthens. Eventually, a structure deep in the brain called the basal ganglia takes over. It bundles that sequence of movements and thoughts into an automated routine, shifting the action from conscious strain into effortless muscle memory to save energy. Your basal ganglia will automate whatever you repeat. It easily absorbs the effortless routine of scrolling through feeds for quick hits of dopamine. But forcing it to automate a difficult, complex skill requires intense, deliberate biological strain. High achievers are simply people who have endured that initial strain. They systematically force their basal ganglia to automate difficult, productive processes instead of passive, cheap consumption. Extreme achievement requires the active programming of specific neural circuits to completely override the body's default biological responses under pressure. When you look at Michael Jordan, you are looking at someone intensely focused on process. Jordan famously visualized the exact physical sequence of his movements, the grip, the release, the follow-through, rehearsing the mechanics over and over in his mind before he ever stepped on the court. By mentally repeating those steps, Jordan was firing the neurons in his motor cortex. He hardwired the circuit through sheer repetition until his execution became an entirely automatic procedural memory. Michael Phelps programmed his brain differently. Every night before sleeping, Phelps visualized worst-case scenarios, like exactly what he'd do if his goggles snapped and his eyes filled with water mid-race. Phelps wasn't training his motor cortex, he was actively training his prefrontal cortex. This is the brain's decision-making center, and he was teaching it to override the natural biological panic that usually takes over when something goes wrong. When Phelps actually dived in and his goggles did fill with water during an Olympic final, his limbic system didn't shut his body down with fear. His prefrontal cortex experienced the threat thousands of times and knew exactly how to navigate it. Then there is Napoleon, who operated from a completely different structure, the amygdala. Before a battle, Napoleon would imagine every possible way he could die, using pure threat detection and fear to map out his survival. Running your life from the amygdala is highly effective for surviving a battlefield, but it comes at a massive biological cost. Operating out of chronic fear floods the body with cortisol, exhausting the nervous system and taking a physical toll over a lifetime. While inherent ability sets the baseline, elite performance is refined through the deliberate selection of which neural circuits drive your behavior. You are effectively choosing the driver for your own biological machine. This chart plots human neuroplasticity across a lifespan. The brain is incredibly moldable and open to new wiring during your first 25 years, but after that, the pathways begin to rigidly set in place. If you take that aging, rigid brain and feed it a continuous diet of cheap dopamine, the data reveals a harsh reality. High passive consumption actively shrinks the volume of the hippocampus and directly weakens your executive function. To fight this decline, you have to apply positive stress. Neuroscientists call this neurobics, the deliberate practice of forcing your adult brain to abandon its comfortable, automated shortcuts. When you learn a complex new language, pick up a musical instrument, or even just brush your teeth with your non-dominant hand, you force those once dormant, inactive neural branches to suddenly spark back to life and rapidly forge new, glowing physical connections. Choosing to do difficult things fulfills a literal, biological requirement for upgrading your mind's hardware. Your brain automates whatever you feed it, making you the primary architect of its future structure.